And the p orbital has two parts. Actually, all orbitals have two parts. We kind of ignore that for S's because it just gets more complex than we want to get in high school chemistry, okay? All right, and then we got an orbital that's got to come out from the paper. Well, I have no way of drawing an orbital coming out from the paper. I mean, I could take some glue and stick it on there and make it stick up, but how am I going to stick it behind? I'd flip it over, okay? So we need a way to kind of illustrate another orbital that's not really where these are showing up to be, okay? And so we kind of usually draw this so that it's kind of coming out toward you, and the other one's kind of back here behind, okay? And this one, the top half of this is our orbital, okay? Now, so imagine I take this and just these little parts of the orbital and stick it inside that instead. It becomes kind of hard to even figure out what's going on. So it's probably better if you imagine them being there without me actually putting them there, okay? Are you with me so far? Okay, so this is actually representing the actual shape of these S and P orbitals up here. Okay, those boxes are bookkeeping systems. They're not the actual shape. Okay, in fact, drawing physical representations of them is really not very fair anyway when you start to kind of understand a lot more about it. Okay, these are clouds. Well, clouds don't have edges. Now, if you stand a long way back from a cloud, it looks like there's a nice edge on a cloud, right? How many of you have flown on an airplane? Have you flown through a cloud? Okay, so you're flying in a nice blue sky, and suddenly it just starts to get a little fuzzy, and a little fuzzier, and then all of a sudden you're inside this cloud. There's not a real nice edge there. It just kind of looks like it from a long way away. Does that make sense? Those of you who've never flown in an airplane, you probably won't have a clue what I'm talking about. But that's what happens. Well, the electron cloud's the same way. This is representing a probability. 90% probability, actually it's more like 93, 94, that the electrons are found in these regions. Okay? And they're in that region because after I cancel the electromagnetic repulsion with opposite spins, those pairs of electrons can't oppose each other. They can't actually be in the same physical space. They're pulled in by the nucleus because it has an opposite charge, but they can't actually be in the same physical space. They have to kind of separate themselves a little bit. All right, you with me so far? Nobody's saying anything. Okay, you with me so far? Okay. When we get to bonding, that becomes important in understanding S and sigma and pi bonding. Okay, single and double and triple bonding. All right, because for the same reason that these form different orbitals, those bonds have to be physically located in a slightly different place. Okay, we'll get to that. We haven't gotten there yet. All right, so that's where we are so far. Okay, I think I brought you up to speed on everything so far, and we kind of got an idea of why it is you're labeling these periodic tables. Okay, so let's make sure we're clear on the remainder of the periodic tables I want you to finish labeling. Okay, have we done representative elements? Okay, now if you haven't, write it down. You gotta make sure you have in your notes, in your homework, outline where the representative elements are on the periodic table. Okay, so the handout I gave you has that. Okay, the sublevel regions, I just showed you that. You're supposed to have already done that one. Atomic radii, have we done that one already? Yes.
The third one down?
Yeah, I think that's atomic radii. Okay. Same thing. Radii means from the nucleus to the outer edge, and that's basically the size. Okay. If it has a longer radii, it's got a larger size. Does that make sense? Okay. All right. So let's see. Then we want to do the pattern of ionic radii. That gets a little more complex, but it's in your handout. I want you to draw it out for yourself. Okay. You draw it out for yourself because just looking at it and trying to commit it to memory is not as an effective method of learning as drawing it out for yourself. Drawing illustrations is a helpful way to learn. Okay? Anybody ever told you not to doodle? Huh?
I'm saying they're wrong.
I'm saying they're wrong. Okay? Doodling, if it's used properly, has a solid educational foundation for learning. But you have to use it for the right thing. If you're doodling about something that has nothing to do with your lesson, then that's not helpful. Okay? What?
Is this one for the fourth one?
Does it say ionic size or ionic radii? Oh, or does that say atomic radii?
It says ions on energy or something like that.
Well, we'll get to that.
Okay.
Okay? I think you're talking about something else here. It says ionic size right here. Okay?
Okay.
And there's a 3D periodic table. And I don't have an outline for you. I have numbers here for you showing ionic radii. You have to figure out how to illustrate this one yourself.
Okay.
So up until you get to that one, you know, you kind of got a pattern to follow. You just copy it down. But now you got to figure one out for yourself. Okay? So positive ions get smaller and smaller and smaller as they go across a row. Okay? Then suddenly I get the negative ions and they just jump way up. And that's the important concept here you need to know. Positive ions get smaller as you go across a row, even though you're adding more stuff to it. You add more protons and neutrons to get them to be a different element as you go across the row, but they get smaller as you go across the row. And we'll explain why that is later. We'll talk about something called the shielding effect. But then when you get the negative ions, they jump up in size. Okay? So you have to illustrate that pattern on a periodic table. I've given you outlines to work with. Okay? All right. Pattern of electronegativity. That's one you need to be able to do. If you haven't done it already, you need to get it done. That's a pretty simple pattern, but it's an essential thing for you to know for the entire semester. Electronegativity is going to be very, very important in here. Okay? Got it? Then you're going to have the pattern of first ionization energy. First ionization energy. I don't think I've assigned that one yet, have I? Okay, so that's one you're going to have to do tonight if you haven't done it already. First ionization energy. What? Okay. Now, by the way, I've been sending this stuff to you by email. If you got your email set up, you can find all this stuff in your email. All right? Helps you out a lot, I hope. Okay? All right. After first ionization energy, you've got to have electron affinity. Okay? Pattern of first ionization energy and pattern of electron affinity. Those are like two opposite things. Electron affinity is the opposite of ionization energy. Okay? At least that's the way I like to think about it. All right. Then we got to have a pattern of element reactivity. Element reactivity is another one. What? Are you out of periodic tables?
Yeah.
Well, you print them out, right? I sent them to you by email. They're there. If you want me to print one for you, you can see me after class or after school. Or you can draw one out yourself. It's not hard to draw one of these patterns, is it? Okay? I've given you 6 of them. You can draw the others. It's not that bad. Okay? Pattern of element reactivity. All right. Then I want you to locate regions with special family or group names. Regions with special family or group names. Now, I don't think the handout that I gave you guys had that on there, but if you look on your email, you'll find it. Okay? Again, if you want me to print you one out, I can do that, but I'm trying to encourage you guys to use that school email. Okay? This is what the patterns of family names look like. Family and group names look like. Okay? And the last one you're going to have to do is the location of metals, nonmetals, and metalloids. Metals, nonmetals, and metalloids. Okay? You probably did that when in physical science. Or at least you were taught about that in physical science. Okay? If you look on your main periodic table, this stair step right here that I gave you in your handout and your test references that you have your copy of it. If it's on this side to the left, all of these are metals. If it's over here on this side, all these are nonmetals. And most of the elements that touch two sides or two parts of this stair step are called metalloids. Now, aluminum is an exception; it's always a metal. But boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and acetine are all metalloids. Okay? And I've got a pattern here laid out for you to use to make your own. Okay? Have you ever heard of learning styles? You ever heard of learning styles? Ever taken a learning styles test? Okay? Well, I want you to hear it from me. That's bogus. Okay? It is true that certain students prefer to learn in one of those learning styles. But what gets lost in all that is everybody learns equally well in any of those learning styles. Okay, you might prefer one or the other, which is fine. Okay? But everybody learns from any of those learning styles. So, the claim that I can't learn from hearing it or I can't learn from, that's bogus. I'm sorry. You learn from all those things and they all reinforce each other. So by reading it, you learn. By hearing it, you learn. By writing it down yourself, that's kinetic learning. Okay? They all reinforce each other. I'm giving you lots of different ways to reinforce this knowledge. Okay? So we'll be going over these things in class, but I want you to have written down a pattern for yourself, kinetic learning, all right, before we do that. You with me so far? You know what your homework is as far as labeling periodic tables now, right? If you've done them twice already, it shouldn't be hard. It should be pretty quick before you get that done. Okay? So I will also assign something else here before we leave class today, okay? Just to reinforce things we do in class. Most of the homework I assign is reinforcing things in class. Okay? All right, I'm going to stop the capture here.